Hello there and welcome to Help Grow Academy. In today's class, we'll be solving over 10 most repeated POST UTME questions. Please don't forget to hit the like button, subscribe to this channel and turn on your notification bell so you get notified whenever we upload a new video. The first question we have today says, a wire of length 2 meters is stretched by a force such that its extension is 0.5 meters. If the Young modulus of the material is 2 times 10 raised to the power 11 Newton per meter square and the cross-sectional area is 1 times 10 raised to the power minus 6 meters square, what is the force applied? Option A says 50 newtons, option B 100 newtons, option C 200 newtons, and option D 1000 newtons. Now, they said if the Young modulus Y is given by the formula stress over strain. Young modulus is a measure of stiffness and it is given by this formula stress over strain. Stress here is equal to force over area. Stress simply means the force acting per unit area. We have the next, which was strain. Strain here talks about the extension acting per unit length. We have E over L, where E here stands for the extension and L here stands for the original length. If we substitute this into this equation, we have Young modulus Y is equal to stress over strain. Stress here is force over area, all divided by what? Strain, which is extension over original length. We can rewrite this as saying Y is equal to F over A, which is the stress, divided by E over L, which is strain. From mathematical expression, when you have something like this, two fractions dividing themselves this way, what you need to do is take the inverse of the second fraction and change the sign from division to multiplication. If we do that, we're going to have F over A times, this denominator here comes up, we have L over A. This will give us what? F times L will give us FL over A times E will give us AE. Therefore, the formula for Young modulus Y is equal to what? FL over AE. The question said we should find what? The force. So from this equation, we'll make force the subject of formula. If we do that, we're going to have Y is equal to FL over AE. When we make force here subject of formula, we're going to cross multiply. This is same times over 1. When we cross multiply, we have this times this, we have FL is equal to YAE. We divide both sides by L. This will take away this. F is equal to YAE over L. So this is the formula now we're going to use. Note, from the question we were given, the question says a wire of length 2 meters. So they give us L to be what? 2 meters. Is stretched by a force such that its extension, they give us E, extension to be what? 0.5 millimeters. If the Young modulus of the material is 2 times 10 raised to the power 11 Newton per meter square, so they give us Young modulus Y to be 2 times 10 raised to the power what? 11 Newton per meter square. And the cross-sectional area, they give us area to be what? 1 times 10 raised to power minus 6 Newton per meter square. The question says what is the force? So the force is unknown. Now we have this formula here where we have gotten the force. So to find the force now, we make use of this formula. To find the force, we make use of this formula. From this formula, if we substitute these values into this equation, we have F is equal to Y. Our young modulus is what? 2 times 10 raised to power 11 times A. Our area here is what? 1 times 10 raised to power minus 6. So area here is in meters square, not. Our E here, which is the extension, is what? 0.5 millimeters, all divided by L, which is the length. L is what? 2 meters. If you put your calculator correctly, this will give us what? 200 newtons. Cross-check it and tell us if you are correct in the comment section. Question 2 says, a gas expands adiabatically from the volume, which is V1 is equal to 1 cubic meter, to V2, which is 4 cubic meter. If the initial pressure is 8 times 10 raised to power 5 Pascal, and gamma is 5/3, what is the final pressure? A, 2.0 times 10 raised to power 5 Pascal. B, 1.0 times 10 raised to power 5 Pascal. C, 0.5 times 10 raised to power 5 Pascal. And D, 4.0 times 10 raised to power 5 Pascal. Adiabatic means a thermodynamic process where there is no heat exchange with the surrounding. There is no heat exchange between the system and the surrounding. From adiabatic equation, we have that P1 V1 gamma is equal to P2 V2 gamma. Right? This equation is called an adiabatic equation, where P1 is the initial pressure, V1 is the initial volume. Here is the gamma. This is the gamma. P2 is the initial pressure, is the final pressure. V2 is the final volume, and this is our what? Gamma. From the question, they said a gas expands adiabatically from volume V1. So they gave us V1. V1 is equal to what? 1 meter cube. They also gave us V2. V2 is what? 4 meters cube. They say if the initial pressure is, so they gave us P1, the initial pressure to be what? 8 times 10 raised to power 5 Pascal. And gamma, they gave us gamma to be equal to 5/3. Now from this equation, we have everything here except P2. So we're going to make P2 the subject of formula. If we do that, we'll divide both sides by V2 raised to power gamma. We're going to have P1 V1 over V2 gamma is equal to P2 V2 raised to power gamma all over V2 raised to power gamma. Here, this will cancel this, we're left with what? P2. So this equation gives us P2 is equal to this, the whole of this, P1 V1 gamma divided by what? V2 raised to power gamma. Now something is common here, right? This is V1. Something is common here. So we can rewrite this equation as P2 is equal to P1 V1 divided by V2 all raised to the power of what? Gamma. Because both of them are raised to the same power. So we divide the both of them and raise them to one particular power. So from this equation now, if we put these values into this equation, we're going to have P2 is equal to what? P1. The value for P1 is what? 8 times 10 raised to the power 5 Pascal into our V1. Our V1 is what? 1 over our V2, which is what? 4. All raised to power gamma. Gamma is given to us from the equation as 5 over what? 5 over 3. Now if we simplify it, we have P2 is equal to 8 times 10 raised to power 5. From board mass, let's simplify the one in the bracket first. If you simplify this further, you're going to have 0.125. Now 8 times 10 raised to power 5 multiplied by 0.125, you have 1.0 times 10 raised to power 5 Pascal. Now this gives us option B to be our correct answer, 1.0 times 10 raised to power 5 Pascal. Question 3 says, a wave has a frequency of 500 Hz and a wavelength of 0.68 meters. Calculate its speed. A wave has a frequency of 500 Hz and a velocity and a wavelength of 0.68 meters. Calculate its speed. Option A, you have 320 meters per second. Option B, you have 340 meters per second. Option C, you have 360 meters per second. And option D, you have 400 meters per second. Now from the question, what we are given? We are given what? Frequency, right? Frequency is equal to 500 Hz. We are also given something, wavelength. Wavelength was given to us, that is lambda, to be what? The wavelength is 0.68 meters. They say find the speed. That's the wave speed. Wave speed is given as what? V. V is unknown. Now recall the equation for wave speed. The wave speed is given by the formula V is equal to F lambda, where V here is the wave speed. V is equal to 500 times what? 0.68 meters. 0.68. When you multiply these two together, let's do that, and that gives us our final answer. 500 times 0.68 will give us what? 340 meters per second, thereby making option B the correct answer. Question 4 says an electric field of strength 200 Newton per coulomb acts on a charge of 200 microcoulombs. What is the force experienced by the charge? They gave us option A to be 2 times 10 raised to the power minus 4 newtons. They gave us B to be 4 times 10 raised to the power minus 4 newtons. C is 2 times 10 raised to the power minus 6 newtons. And D is equal to 4 times 10 raised to the power minus 6 newtons. Now from the question, we were given what? They gave us electric field strength, which is what? Electric field strength is given by the formula, or is noted by letter electric field strength is denoted by letter E. And from the question, it is 200 Newton per coulombs. They also gave us the charge. Charge is noted by letter Q, and it is given as what? 2 microcoulombs. 1 microcoulomb is 1 times 10 raised to the power minus 6. So this is 2 times 1 times 10 raised to the power minus 6. This is for 1 coulomb. For 2 coulombs, it's going to be 2 times this value. For 3 coulombs, it's going to be 3 times this value. So it's going to give us 2 times 10 raised to the power minus 6 coulombs. Recall that the formula for electric field is given as this: E is equal to F over Q, where F is the force, E is the electric strength, and then Q is the charge. If we make F the subset of formula here, we have F is equal to EQ. This will give us our E is what? 200 times our Q. We have it to be 2 times 10 raised to the power minus 6 coulombs. Let's remove the units. We have 2 times 10 raised to the power minus 6. 200 times 2 times 10 raised to the power minus 6 will give us 4 times 10 raised to the power minus 4 newtons. Don't forget, force is measured in what? In newtons. Now the final answer is 4 times 10 raised to the power minus 4 newtons. We'll move over to the next question, question 5. Question 5 says, a body of mass 5 kg. So they give us mass. A body of mass 5 kg is suspended from a spring and causes an extension of 10 cm. They give us extension to be 10 cm. So we have extension to be 10 cm. This is for mass, and this is for what? Extension. If they calculate the spring constant, K is unknown. This is the spring what? The spring constant. They also gave us from the question that we should take acceleration to gravity G to be 10 meters per second squared. Now from the question, if we recall Hooke's law states that the force is equal to what? Kx, where K is the spring constant and X is the what? Extension or elongation. Now we have the value for what? We don't have the value for K, but we have the value for X, and we have mass. Recall that F is equal to what? mg. Force is equal to mass times what? Gravity. They gave us, don't forget, they gave us mass, and they gave us what? Acceleration due to gravity. If we substitute this equation, we have F is equal to mg. Our m is what? 5 kg times our g here is what? 10. 5 times 10 gives us what? 50 newtons. Now we have gotten the value of F to be 50 newtons. Let's substitute it into this equation. If we put this into this equation, we have F is equal to Kx. This gives us F is what? 50 newtons is equal to, our K is what? Unknown. And our X, the extension, is what? 10 cm. Now, this is in cm. We need to convert this from centimeters to what? Meters. If you convert from centimeters to meters, you divide by 100. Converting this from cm to meters, you will divide by 100. Cm to meters, you divide by 100. So we have 10 cm divided by 100. This take away this, we have 1 divided by 10 will give us what? 0.1 meters. Therefore, we have converted this extension from 10 cm to what? 0.1 meters. We are going to substitute this value now into this place for the x. So for x, we have times 0.1 meters. If we make k the subset of formula, we have k is equal to what? 5 50 divided by 0.1. 50 newtons divided by 0.1 meters. When we do the division, we're going to have 50 divided by 0.1 will give us 500 Newton per meters. Therefore, the spring constant in this question is given as what? 500 Newton per meter. This is the final answer. Question 8 says an object is dropped from 100 meters tower. What is its velocity just before hitting the ground? Take acceleration to gravity to be 10 meters per second squared. Option A says 40 meters per second. Option B, 44 meters per second. Option C, 45 meters per second. And option D, 50 meters per second. From the question, an object is dropped from a height. We have height to the what? 100 meters. It says, what is its velocity before hitting the ground? That is the final velocity. V is equal to what? Unknown. We don't know it. From the question, they gave us acceleration due to gravity to be 10 meters per second squared. Now, U, which is the final velocity, is equal to what? 0. It was not given to us in the question. Recall the equation of motion that V square is equal to U square plus 2GH. This will give us, this is 0 squared. V square is equal to 0 squared plus 2 times 10 times 100. This is equal to what? V square is equal to 2 times 10 is 200. 200 times 100 will give us what? 20,000. So you have 20,000. We are looking for V and not V square. So we take the square root of both sides. If we take the square root of both sides, we have V is equal to square root of 2,000, 20,000. This will give us what? 44.7 meters per second. If we convert, if we approximate this, we're going to have what? 45 meters per second. This is the final answer. So the correct option there is option C with 45 meters per second. Question 9 says 2 capacitors 4 microfarad and 6 microfarad are connected in series. What is their effective capacitance? 2 capacitors 4 microfarad and 6 microfarad are connected in series. What is their equivalent capacitance? We have the options there, A, B, C, and D. The term capacitance simply means the ability to store electric charge. For series connection, we have 1 over the equivalent capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over Cn. So any number at all, any number of capacitance. From the question, they gave us C1, which is the first capacitance, to be what? C1 is given to us in the question to be 4 microfarad. They gave us C2. C2 is given to us as what? 6 microfarad. Now, if you substitute this into this equation, we're going to have 1 over C equivalent to be 1 over C1. Our C1 is what? 4 plus 1 over our C2 is what? 6. This is equal to, when we have two fractions like this, we take the LCM. The LCM of 4 and 6 is what? 12. 12 divided by 4, you have 3. 3 times 1, you have 3. plus 12 divided by 6, you have 2. 2 times 1, you have 2. This is giving us what? 3 plus 2 will give us 5 all over what? 12. We have the equivalent capacitance to be what? 5 over 12. Now at this point, we are looking for the equivalent capacitance and not 1 over this. We are just looking for this. So for us to remove this numerator, we take the inverse of both sides. This becomes C equivalent over 1 is equal to 12 over 5. Anything divided by 1 is that same thing. So we have C equivalent is equal to 12 divided by 5. We have 2.4 microfarad. So this is our final answer. The correct option there is option B, 2.4 microfarad. Question 10 says a uniform rod of length 2 meters and mass 3 kg is pivoted at one end. What is its moment of inertia about the pivot? What is its moment of inertia about the pivot? A, 1 kg meter square. B, 2 kg meter square. C, 3 kg meter square. And D, 4 kg meter square. Don't forget, from the question they gave us what? Length. Length is equal to 2 meters. And they gave us mass. The mass is equal to what? Mass is equal to 3 kg. Now, having done this, he said it is pivoted at one end. Moment of inertia simply means resistance to rotational motion. And mathematically, it is represented as I is equal to 1 over 3 ml squared. We have the mass, we have the length. We are asked to find the what? The moment of inertia. So I is equal to 1 over 3 into, our m here is what? 3 kg. Our length is 2 all to power 2. This will give us 1 over 3 into 3. This is 4. This will cancel out. We have what? 1 times 4. 1 times 4 will give us what? 4. Therefore, the moment of inertia is we have come to the end of today's class. Please don't forget to hit the like button, subscribe to this channel, and tell us other topics or subjects you'd like us to treat. Till then, see you in our next video.